So far in our environment using RIP, what we've done is we've illustrated the fact that we've got basic configuration, we've talked about authentication, we've even talked about the behavior of RIP with regard to physical interfaces that are operating in the unison with non-broadcast multi-access technologies like DMVPNs, what used to be done predominantly using frame relay. Now, in the confines of the rest of our conversations, what we want to do is we want to start focusing on the idea of the fact that I can be selective as to how I wish RIP to behave. What I want to do is highlight, just like we talked about in our theoretical conversations, and that was the fact that RIP version 2, or first of all, RIP v1 used to operate using broadcast addresses. So it was 255, 255, 255, 255, and I'll get my head out of the way here. Now, with regard to that, version 2 changed that behavior to use multicast, now using that 224.0.0.9 multicast address with a source and destination of UDP 520. We saw that in the previous presentation. Now what I want to highlight is the fact that this behavior can be selected on a link-by-link basis as well as based on global configuration. So what I can do is we've already said that we want the system to operate using version 2. And it's going to be on all interfaces, and we did that via the router configuration command of version 2. Now what if I wanted to revert to version 1 on an individual link? Let's see what happens when we do that. And what we'll do is we'll pick the link connecting R4 and R5. That's not what I wanted to do. Connecting R4 and R5. And what we're going to do is we're going to change this to a broadcast connection. Let's take a look at it. So what I'm going to do is I'm going to go under my individual interfaces on R4 and R5. So let's cut in here and take a look at what we've got on R4. Do show CDP neighbors. And I wanted to connect to R5, so I'm using 00 on both of these interfaces. Let me just annotate this real quick. 00. All right, now with that being said, let me go ahead and take some of this stuff off right here, because what I want to do is I want to clear the screen up a little bit. So the main idea was that we wanted to change our operational requirements to broadcast. Well, what we'll do is I'm going to go into that interface E00, and what I want to do now is I'm going to tell it how I want it to operate. Now I can do this by specifying the IPRIP command, and what we're going to see here is I have the capability of adjusting receive and send. I also have the capability of sending IP broadcasts messages. So let's do that. So first of all, what I'm going to say is I'm going to say IPRIP v2-broadcast. Now, let's see what happens on this link. Do show IP route, pipe include via 10.1.45.5. Well, everything right now is at 10-second intervals. So let's see what happens. 16. Let's see if it cuts above 30 and see if it changes our behavior. 22. I'm looking at this timer right here. Didn't mean to do that. And it's resetting. Well, the point here is what's happening then? So let's come in here and say this right here. Exit. Let's debug IP RIP. And this is what our messages tell us. Just waiting for a few of these to scroll through. Well, it's on R4. So far, we're not seeing anything out of the ordinary. Let's see if we're receiving anything on 5. Show CDP neighbors. Let's make sure it's the right interface. We should be connected to 4 on 00, which we are. So debug IP RIP. Let's see what's happening now. Let's see if we're receiving any updates. Well, we got a bunch of updates here. That's sending. Sending. Let's keep waiting. See what happens. Well, here we have the tunnels. So there's tunnel 0, tunnel 0, tunnel 0. So that's 21, 20, and 19. Via 00, we received a V2 update. So we are receiving information across, but let's look at the nature of that information. So let's UAll this. And what I want to do right now is I want to say debug IP packet detail. Now the other thing I'm going to do is I'm going to fire up a Wireshark session. Just give me one moment. While this is percolating. Always takes a little while. I apologize for that. All right, trace is running. Well, we see some interesting information just in the screen right now. UAll. Whoop, no, UAll. Let's scroll up and see what we've got going on here. Notice now we start seeing information that isn't just on 224.0.0.9. We're also starting to see information associated with the all broadcast address. Let me find it. There it is. So we got this from R4. It was destined to 255, 255, 255, 255.0, or I'm sorry, all 255s, input feature, source destination. And the main thing that we need to recognize here is that when we looked at how we're going to be processing this, it's coming, but the point here is that we are actually sending this as broadcast, but the question is are we still sending multicasts? So what I'm going to do is I'm going to go and bring up my trace, and let's see what happens when we look at this from the point of view of R5. So I got R5. Well, let's see here. We'll go R4, 0, 0. Just give me one moment. I'll move this stuff out of the way since the trace is still going. And now what I want to do is I'm going to type RIP. I only want to look at RIP information that I have going. Now, when we look at this, notice that we are sending a multicast and we're sending a broadcast. So let's take a look at exactly how this is going to play. So RIP routing protocol. Notice inside of this broadcast update, it's a version 2 update, and notice it's giving me information about different prefixes. 44, 101, 104, 210, loopbacks for R4, R1 for the loopback from R3, I'm sorry, from Cat2. Gives me everything about them to include the mask information and the metric. So again, all interesting components. Now let's take a look at this multicast range here. So looking at this also, we see that we're learning prefixes. /32 coming out here is again, we're learning each of these different components. And again, notice it come up and it said that we're using UDP port 520 in order to be able to send the information. So all I'm illustrating here is that by virtue of the fact that we have told it to use broadcast, we have not turned off multicast on this interface. So when we go in and we look at this, one of the things that we may want to be able to do is alter the behavior. Well, we've discussed two components. We've talked about MCAST which was originally 2.224.0.0.9. We talked about broadcast behavior, which is going to the all 255s. But what about unicast? Can I send my updates via unicast? Of course I can. And again, when we do the configuration, we're going to find out that we do it under the config for the routing process. So on R5, it's going to be router RIP. And what we're going to do is we're going to say neighbor, and I'm going to specify the identity of my neighbor, 10.1.45.4. And what I'm going to do now is just hit enter. Now, this is going to change behavior again. So let's take a look and see what we got going on. So debug IP RIP first. We may take a look at debug IP packet. Now let's see what's happening on this link by itself. I want to see a send. Loop back. While this is running, let's go ahead and see if we can't grab another output from R4's 00 interface. And let's look at RIP specifically, RIP. Well, now we see a lot more information. And here's the one that I want to look at right here. Notice we have an update that's going out. That update is sourced from 10.1.45.5 destined to 10.1.45.4. That is now operating via unicast. We're sending our updates via unicast, but the thing that I want to point out here is also notice that we're still sending messages using multicast and broadcast. So if I wanted to change the behavior on this device, first of all, I want it to operate purely using unicast. So let's take a look at the config for that. UAll config T router RIP. And what am I going to specify? I'm going to specify the command passive interface. Passive interface allows me to stop the multicast broadcast behavior on any given interface. I'm going to say interface Ethernet 0, 0. Let's cut over to R4 and do the same thing. Config T router RIP passive interface E00. Show IP route. Let me UAll this. Show IP route. RIP pipe include via 10.1.45.5. And let's see what we've got going on now. So let's let this percolate just a little bit, and we'll see what's going on. While that's happening, I'll go ahead and verify my config. So show run section router RIP and show run section router RIP. Okay, so we have my passive interfaces here. We've got a passive interface command here. Let's go to 5. Where's my neighbor command? There it is. So let's see what's happening now on R4. Take a look at the routing table again. Well, this tells me that I'm updating. Show IP route. Let's see if I got any routes in here that are getting old. 15 seconds on 00. Well, let's do this. Do show or show run pipe section router. Let's passive. Let's see, it is passive here on 4. And it is passive on 0. Show IP route. Okay, now we got something going on here. Look at this. It says via 10.145.4. Notice it's telling me that it's aging out. So let's see what's going on here. So show IP route 10.1. Show IP route RIP pipe include via 10.145.4. Oh, include. Notice they're all aging out. Everything that we're learning from that link is aging out of our routing table. Now, the reason it's aging out of our routing table on this side, let's take a look at our config. Do or show run section router. The neighbor statement, let's go over to R4 and see if anything's aging out of this table. Show IP route RIP pipe include via 10.145.5. But nothing's aging out on this side. Nothing at all is aging out on this side. That's interesting. Well, let's do this. Let's go back over to R5 and let's remove the neighbor command. Router RIP no neighbor 10.145.4. Do show run section router. And now the neighbor command's gone. Passive interface is going. Let's see now what ends up happening here. Let's refresh this output here. 23 seconds, 24 seconds, 27 seconds, 29 seconds, 30 seconds, 32 seconds. We broke it. Now, how did we break it? Well, we broke it because on the link connecting R4 to R5 using Fast Ethernet 00, what we did is we said passive interface. Now, the passive interface says to stop listening to multicast and broadcast traffic. Now, by virtue of the fact that we've done this on both ends of our link, the net effect is we have killed this connection for the purposes of exchanging RIP updates. Now we corrected that because remember over here on R5 we used the neighbor statement. The neighbor statement that went to 10.145.4 was able to get updates to R4. And those routes appeared in my routing table, in my RIB. Let's reproduce that. So we'll go over to R5 and put that command back. Config T, router, RIP, neighbor 10.145.4. Now before we do that, let's cut back over to R4 and I want to see if these are in my table. And they are. So what I'm going to do is I'm going to say clear IP route star and see if I'm learning anything via 10.145.5. Let's wait and let's let it percolate just a little bit. RIP is so slow, but I'm going to show you how to speed it up here very shortly. But even then, you're not going to be able to speed it up a huge amount. But the main thing is realizing the fact that we can at least alter these timers, make them shorter. And we're not learning anything, and that's to be expected. So what I'm going to do is I'm going to go over to R5, and now I'm going to send that neighbor statement. I'm going to put that neighbor in that says use unicast updates to get information to R4. The moment that I do that, I should start receiving some information, but let's take a look and see, because remember, it's going to take a little bit of time. Show or debug IP routing, and let's see what happens. End. Debug IP RIP. Let's see if we send any information out now. We received information. Loop back 0. We're ignoring the one coming from ourselves. That's to be expected. That's off the tunnel. There we go. That one was off the interface. UOL. Okay, so let's scroll up here and we see that's off of 01. Here we go. We're sending updates now to 10.1.4.5.4 rather than sending it to the multicast address. And when I come over here, I should see prefixes, which we can see right here. You can see the output of where it's added and updated prefixes. Now I'm learning everything that I want to learn. Now here's the issue, because on R5, you all show IP route RIP pipe include via 10.1.45.4, I'm not learning anything from there. And the reason being is it's not sending me information that I can interpret. I need to go over now, because we've disabled multicast and broadcast as an option on this link. I need to go over and tell it to use unicast, which means I need to do this on both sides of a link if I'm going to do this method. You all config T router RIP, and I'm going to say neighbor 10.1.45.5 and hit enter. Now the moment I do that, debug IP routing, we should see information populate the table. And debug IP routing allows me to see the results of the computational processes that run. Okay, here we go. Updating RIP, we're learning information. We're learning information. 0, 1. Let's see, have I got anything here for 0, 0? 0, 0. So now, you all, I should be learning prefixes from 10.1.45.4. So this is going to be the explanation of broadcast operation and multicast operation and unicast operation. The point is that if I go in and say that I want to use unicast operation, that does not mean I have stopped using multicast or broadcast, depending on which version of RIP that I'm running. So in order to be able to stop using multicast and broadcast, I need to passive the interfaces out. By doing that, I'm not going to be listening to multicast information coming across, so I'm not going to try to use multicast to be able to form my neighbor relationships. So keeping in mind, if you're ever instructed to use unicast for the purposes of exchanging prefixes and unicast only, remember that you're going to have to passive interface the interface upon which you're going to be running your unicast updates. So never lose sight of that fact. Now, with that being said, we've gone through that. Now, there's one other element that I want to be able to walk through, and that's going to be the ability to be able to take these links by link and determine whether or not I want to send version 1 or send version 2 updates. Let's look at that. So what I want to do is I'm going to pick another device. Let's say I'll pick R1. What I'm going to do is I'm going to come onto R1 and I'm going to say interface E00. And what I'm going to do is I'm going to say IP RIP, and the other set of commands that I want to use are going to be send and receive. Now what I can do is I can come in here and I can say send version 1, do show IP protocol, and notice now I'm sending version 1 updates. So by sending version 1 updates, that means I'm sending multicast addresses. I can also configure it to where I wanted to send and receive each of these. Now the interesting point here is that if you remember, do show run section router, what we did is we went in and we hardwired for version 2. Now let me go ahead and take this command off. No IP RIP send version 1, do show run interface E00. Now gone. Router RIP no version 2. Show IP protocols. Notice right now what's happening is I'm sending version 1 updates, but I will have the capability of processing version 1 and version 2 if they are sent to me. So if I want to fix this to where it's version 2 across the board, I can either do this through the interface manipulation. So come back interface E00. IPRIP send version 2, IPRIP receive version 2. Do show IP protocols. Now notice this is the same, or as I did it previously, router RIP version 2. Do show IP protocols. Now what we're going to see is everything is going to be sending and receiving version 1 and version 2. Is this something that you're going to do in the real world? No. Is this a corner case scenario that you may be asked to be able to perform in the lab? It could be. It's probably not very likely, but it's in our best interest to make sure that we know about all of these features. And this gives me the ability of being able to address things like what protocols or what methods, multicast or broadcast, am I going to use on a link-by-link basis. Bear in mind, I may have a device that only speaks version 1. It could be an older device. It could be a device that is just in my infrastructure that I don't have control over, and I just need to be able to conform in order to be able to exchange prefixes with it. So keep in mind we have the capability of being able to do this on a case-by-case basis. So with that wrapped up, what we're going to do is we're going to continue our discussions about the RIP protocol, and we're going to start looking at the fundamentals of prefix manipulation with regard to what gets implanted in our routing table and how to do some type of traffic engineering in our infrastructure. I'll see you guys in that video.